stars and how their color is determined, and a lot of it is based on the star's temperature. So the color to temperature ratio is easily translated to the visible color spectrum, and this is kind of a picture or example to show that. And the higher the stellar temperature, that means it's going to be a bluer color, and the lower stellar temperature means it's going to be a reddish color. So you can see that 1,000 degrees Celsius is red, while 2,000 degrees Celsius is blue. Brightness can also determine a star's color, and to know the exact color of a star, astronomers have to use filters to establish the brightness of it, and each filter only transmits one light from a particular band of color wavelengths. And then they use the blue, ultraviolet, and yellow filters, and these transmit these specific wavelengths, and then the brightness measured through each filter is typically measured in magnitudes, and then the differences between any of these magnitudes is known as the color index, and this is kind of a picture to show what they mean by that. And then atmospheres can also change it, the specific elements within a star's atmosphere. So for example, our sun has a lot of helium in its atmosphere, so technically it would fall on the green spectrum or wavelength, but because of the amount of helium present, it glows like a more yellowish orangish color. And then wavelengths, again, the wavelength at which a star emits the most light is the star's peak wavelength, which is that little peak of the curve right there, and that's known as Wien's law, and then the peak is also known as Planck's curve. The color is affected by the rest of the curve though, so when various colors of the spectrum are combined, it appears white, which makes the color of the star appear lighter than the peak wavelength. So like I was saying before, our sun is technically falling on the green part of this graph here, but because of Planck's curve and because of all the colors of the spectrum being combined and it appearing brighter, it appears on the yellow side, as well as because of all the helium present in the atmosphere. And then distance can also affect the color of the star. This is known as the Doppler effect, and it is changed between the distance between the subject and observer. So it's said that if it shifts towards the red end of the spectrum, if the object is moving away, and then if the object is moving closer, it shifts towards the blue end of the spectrum. And then basically distance affects brightness, which in turn affects the color of the star. Thank you for listening, and keep pondering.